So moving ahead with the 9th question, children. What is given? The weight of the body of the surface of the earth is 20 Newton and the radius of the earth is 6,400 kilometers. The weight of a body at a height 6,400 kilometers is. So same like previous one. What is the formula? First of all, find out GH. Formula for GH is G times of R by R plus H whole square. Same as it is. So the value of GH is equals to G times of R. So radius of the earth, how much they have given? 6,400 kilometers. Whole upon, again R is 6,400. Height is 6,400. Whole square. So GH is equals to G times of 6,400 upon, again 6,400 plus 6,400, it is 12800 square. So solving this carefully, we have 0 and 0 gets cancelled, children. The 64 goes 2 times. Hence the value of GH is found to be G times of 1 by 2 whole square is 1 by 4. So what is the gravity value? GH is equals to G times of 1 by 4. So GH is equals to, what was the value of G? Let us take this value of G as 9.8 into 1 by 4. And this is found to be for 2.84416. 2.45 meter per second square. But here they are asking us to find the weight of the body, okay, but not the gravity. So instead of weight of the body is not taken as GH, it should be taken as mg. So better let us multiply this with m only to get a proper answer. Multiplying this with m, we'll be getting mgh. So this is also multiplied with m, they'll get mg times of 1 by 4. This will give you proper result. What is mgh? Mgh is nothing but weight of the body at that particular height. Mg is weight of the body on the surface of the earth. How much it was given? The weight of the body on the surface of the earth is given as 20 Newton multiplied by 1 by 4. This is better. And this is found to be 4 goes 5 times, children. So 5 Newton. So correct option is 5 Newton. So option B goes good. That's it. So as you, similar to the previous one, find out the GH, but as you know, need to know the weight. Weight is nothing but mass multiplied by the gravity. So just this weight already given. So new weight you have calculated. Moving ahead with the 10th question, children. A particle taken to the height of 2r above the earth's surface, where r is the radius of the earth. If it is dropped from this height, its acceleration will be. So what is given? Now the height is 2 times of the radius r above the surface of the earth. R is the radius of the dropped from this height. Acceleration will be. Same case, children. The value of acceleration GH is equals to G times of r by r plus h whole square. Okay. So what is the value? GH is equals to G times of r by r plus h whole square. What is r? R is the radius of the earth. They considered it as RE. So again RE plus how much height they have considered? Height is h is 2RE whole square. Or GH is equals to G times of RE upon RE plus 2RE is 3RE whole square. So RE gets cancelled. Therefore, the value of GH is found to be G times of 1 by 3 whole square is 1 by 9. So what is the acceleration due to gravity at this height? It is equals to original acceleration due to gravity on the surface of the earth times of 1 by 9. So substituting those values on the surface of the earth, the value of G is 9.8 and multiplied by 1 by 9. You'll getting it this as 1.0. You already saw this in the previous problem. Something like this you are getting. And approximately you can take it as 1.09. Is that so? Well, Okay, 1.09 meter per second square, but nowhere you can see that 1.09. Let us simplify it further. So this can 9, if it is rounded off further, you'll be getting it as 1.1 meter per second square. So this is the nearby value, hence option C must be true. Okay. So we already saw earlier, we took it as 1.09. Further rounding off gives you 1.1 meter per second square. Let us look at the 11th question, children. Two bodies A and B having masses m and 2m respectively kept at a distance dr apart. A small particle is to be placed so that the net gravitational force on it is due to the bodies A and B is 0. This model we have already solved in the worksheet number 1, children. Distance from the mass A should be. Well, so solving this further, what is given means two bodies, forces, a small particle placed, the net gravitational force on it is 0. So F, force due to first body and force due to body A, this will be net force, must be 0. This indicates that magnitude of the force acting by the first body is equals to the magnitude of the force acted by the second body. Equal amount of forces are acting in the opposite direction. So what is the magnitude of force given? F is equals to G. Let us, first body mass is, general formula for F is equals to G m1 m2 by r square. M1 is mass of the first body. What is mass of the first body? M. Okay, mass of the second body is 2m. Let us not consider this. Let us picturize this. Let this be mass of the first body A and mass of the second body. And one more body we have to consider. Small particle mass. I consider this small particle mass as some m dash. Okay, the distance between the two is given as d. Two bodies A and B having masses m and 2m respectively kept at a distance d apart. Small particle to be placed so that net gravitational force on it due to the two bodies A and B is 0. Its distance from the mass A should be, this distance, say x, you have to consider. If this is x, this must be d minus x. It asks you to find out the value of x. Just now we consider the force due to the first body equals to force due to the second body. Force due to the mass A on this mass m dash is given Fa is equals to G, mass is m, here mass is m dash, distance is x, G m by x square equals to, here also G, mass here is 2m, mass between these two m dash upon the distance is d minus x whole square. So simplifying this further, we have m dash gets cancelled, g gets cancelled, m also gets cancelled. What are you left with here, children? 1 by x square equals to here 2 by d minus x whole square. That's it. All the values gets cancelled. 1 by x square equals to 2 by d minus x whole square. Bringing this d minus x to the other side, we'll get d minus x whole square by x square equals to, what is left over? 2. Or this can also be taken as d minus x by x whole square equals to 2. So together we will be writing d minus x by x whole square equals to 2. Taking the square root on both sides, we have d minus x by x is equals to root 2. So, separating the variables, d by x minus 1 is equals to root 2. So, d by x minus x by x, I consider it as 1 equals to root 2. Or d by x is equals to minus 1 carry to the other side, you will be getting it as plus 1. So, 1 plus root 2. How much is that? D by x is equals to 1 plus root 2. But what you are asked to find out, its distance from mass A, it's the particle's distance from mass A is x. So you have to find out the value of x. So bringing the x here, taking the other values to the other side. So finally you're getting the result as taking this x other side. So d upon bringing this 1 plus root 2 down. So d by 1 plus root 2 is the value of x. So what is the value of x? X is found to be d by 1 plus root 2. Hence the correct option is option A. So we already solved this model in the previous exercise, children. Just refer through that same. So moving ahead with the 12th question. The height at which a body has 1/4 of its weight when it is on the surface of the earth is. Okay. So what is given? Height at which the body has 1/4 of its weight when it is on the surface of the earth. You are asked to find the value of h. So formula to find out the value of h is GH is equals to G times of R by R plus H whole square. Hope you remember this formula. This height you are asked to find out. GH is equals to G times of R by R plus H whole square. So, multiplying throughout with M, you have MGH is equals to MG times of R by R plus H whole square. MGH indicates the weight of the body at height H. Mg indicates the weight of the body on the surface of the earth. So, this weight of the body at height H equals to weight of the body on surface of the earth upon R by R plus H whole square. But what is given? 1/4 of it, the height at which body has 1/4 of its weight. WH is given as weight on the surface of earth to the 1/4 times equals to W by R plus H whole square. This W gets cancelled. 1/4 is equals to R by R plus H whole square. Taking square root on both sides, square root of 1/4 is 1/2 equals to R by R plus H. What is that? 1/2 is equals to R by R plus. Taking the reciprocals, we have 2 is equals to R plus H by R. Or 2 is equals to, separating the variables, R by R is 1 plus H by R. Bringing the 1 to the other side, 2 minus 1 is equals to H by R. What is 2 minus 1? 1 is equals to H by R. Bringing the R here, R is equals to H. So at what height is the weight becomes 1/4 of it? At a height equals to radius of the earth. At a height R, where R is the radius of the earth. I consider this as capital R, they consider it as smaller. Whatever is that, it is equal to the radius of the earth. The height should be equal to the radius of the earth. Moving ahead with the 13th question, children. At what height will a man's weight be half his weight on the surface of the earth? So, similar problems, children, same as it is. Okay, what is the formula we have to consider? G dash is equals to G times of R by R plus H whole square. The same formula. If you want to consider weight, you have to multiply this with M, then it will become mg dash. Here also, if you multiply with M, it will become mg times of R by R plus H whole square. This is the weight at a height H, WH I consider, and this is the weight at the surface of the world, W I consider, R by R plus H whole square. That's it. But what is height given? At what height will a man's weight be half of his weight? Whatever the weight of the man on the surface of that, this weight is half of it. If here on the earth, if it is W, here it will be W by 2 times of R by R plus H whole square. Simplifying this, children, W gets cancelled. So 1/2 is equals to R by R plus H. Taking the square root, taking the square root of this? What is square root of 1/2? The square root of 1/2 is 1 by root 2. Equals to R by R plus H. Square root of 1/2 is 1 by root 2. Square root of R by R plus H is R by R plus H. So, cross multiply, taking the reciprocal, we have root 2 is equals to reciprocal R plus H by R. Or root 2 is equals to R by R, separating the variables, R by R 1 plus H by R. Bringing this one, root 2 value is 1.414. Bringing the 1 here will become minus 1 equals to H by R. 1.414 minus 1 is 0.414 equals to H by R. Hence, the value of 0.414 times of r will give you the height of the body where weight becomes half. So the correct option is option C, that is 0.414 r. Let us move to the next question, children, the last question, that is 14th question. Variation of g with respect to height or depth is correctly represented as. Children, as we move deep inside the Earth's crust, then we have g proportional to 1 by r with respect to depth. Okay, with respect to depth, we know that the value of g decreases. Similarly, as we move away from the surface of the earth, also the value of g decreases. But the value of g will be maximum at the surface of the earth. So here, not this exactly, the r must be here, children. This must be the value of r. At the surface of the earth, the value of g will be maximum. If you go deep inside, inside the earth's surface, the value of g decreases gradually. Even if you move away from the surface of the earth, then also the value of g is decreases and the value of g is maximum at this position. Hence, the correct option for this is option B is the right option. With this, we concluded with the gravitation chapter and hence the worksheet. So let us move in the next videos. Until then, take care. Thank you.